Here are some basic terms in physics which you would have learnt in 9th and 10th, such as a velocity or a speed. A velocity is displacement by time. Displacement by time. Or a speed is a distance by time. Distance by time. The distance between the difference between displacement and distance is, if you're going to go like this, x and then y, the distance traveled is x plus y, whereas the displacement, which is called a vector in physics, and it's called a vector, which is just a difference, change in the initial position to final position. Subtract this distance is called displacement. The shortest distance is called displacement. The full distance that you travel is called distance. So velocity is distance by, speed is distance by time, velocity is displacement by time, and velocity is a vector, whereas speed is a scalar. So then SI unit for this is meter per second, and this also is meter per second. Distance is meters and time is second. Velocity is distance by time, so, or a speed is distance by time. Okay, so then let's go to acceleration. Acceleration is velocity by time. Okay, that's the speed at which you're accelerating car is velocity by time. Velocity itself is meter per second divided by second, therefore its meter per second square will be the SI unit for acceleration. So you should know that a velocity is displacement by time and acceleration is velocity by time. Okay, so then next is, supposing this is in a straight line motion. This is in a car. If a car is going forward with the velocity, which is meter per second is SI unit, the acceleration will be in meter per second square, because acceleration is velocity by time. This is in a linear motion. Okay, this is in a straight line motion. Similarly, there's a word called linear momentum. Linear momentum. Linear momentum is mass into velocity. Suppose you have a rifle with you and you are trying to trigger it so that the bullet comes out. It comes out with a mass small m and it goes with the velocity v, say. You know that this is called the momentum. Mass into velocity is called momentum, product of mass into velocity. And you know the momentum will remain conserved. So the best example for saying that momentum is conserved is in a rifle. If you're going to shoot the bullet out, it's a small mass m. Bullet has got a mass small m. Okay, but velocity is v. The gun has got a mass capital M, and it's going to as this goes forward, this is going to go backward. That's why the soldiers keep the gun to their shoulder, attached to the shoulder, so that the gun doesn't come and hit back on the shoulder and the shoulder doesn't get damaged. They'll keep it on the body, in the shoulder, on the shoulder, attached to it, so that they move as one unit, so then they don't physically get hurt. And they move with another velocity in the opposite direction. Say, let's call this is capital M, and the velocity which is going to come back is v1. This is small m into v2. Okay, the bullet is going to move forward. You should know that m v1 is equal to m v2, because the velocity of the bullet is so large, that the momentum will be so high, even though the mass is less. Whereas here the mass of the gun is a gun and the body together. Gun and the body together is more. So the velocity will be less. So just it gets adjusted, the mass and velocity, and that's called conservation of momentum. The mass is more here, the velocity will be less. The mass is less here, the velocity will be more. The velocity of the bullet will be so high that it can pierce through a body. So then that's what is conservation of momentum. That's called conservation of momentum, for which you should understand the word momentum is mass into velocity. Okay, this is a note on how momentum is conserved, so basics in physics which you are supposed to know. And the momentum itself is mass into velocity, and the initial momentum should be always equal to the final momentum. So then what is the SI unit of this is kg, and the velocity is meter per second. So it's kg meter per second. So that's the SI unit for linear momentum. These are the extra points I'm telling you for you to understand where momentum comes in physics. So what is velocity? Is displacement by time. So it's meter per second. Speed is a scalar form of velocity, so you can always ignore that. Okay, so then acceleration is velocity by time. Meter per second is SI unit for velocity, by time is seconds, so meter per second square is SI unit for acceleration. You should know the formula and the SI unit. Linear momentum is mass into velocity. You know, as I said, when the recoiling of the gun is the best example, the mass into velocity of the bullet will be equal to the mass into velocity with which the recoil of the gun is happening. So then the momentum word comes across there where it's kg meter per, it's called linear momentum. Let's look at what is a force. Force is represented by F, which is mass into acceleration. Mass itself is kg. So acceleration itself is meter per second square. We just saw that acceleration is velocity by time. Velocity itself is meter per second by second, so meter per second square. So kg meter per second square will be what is force. Force is equal to mass into acceleration. These are basic things you should know. Momentum is equal to mass into velocity. Then pressure is equal to force by area. Force itself is kg meter per second square as per the above formula. By area is meter square. So it's kg meter by meter square second square. The meter get cancelled. So kg per meter per second square will be the formula for, so force per unit area. Force itself is kg meter per second square by meter square. Area is always meter square. Length is in meters. Area will be meter into meter, so meter square. Volume will be meter into meter into meter, meter cube. Okay, so pressure is force by area. Okay, these are the things which you should know already. And apart from that, supposing a body is going to rotate. Okay, take a stone, tie it in a thread and rotate it, whirl it like this. Okay, in a rotation, so far what we taught was about a car going in a straight line. It's called linear motion. Now it's called rotational motion. In a rotational motion, the velocity will not be v, it will be omega, which is called angular velocity. The v that I have specified here is linear velocity. Straight line velocity is linear velocity. We all know that when we run straight, it's very easy to run straight, correct? But we are asked to go around like this. The velocity is, it's very difficult. Yeah. So then thus we know the linear velocity is greater. It's fast. And the relationship between linear velocity and angular velocity is, linear velocity is r times angular velocity, where r is the radius of the circular path. The relation you should know compulsorily is the linear velocity is r times angular velocity. Angular velocity is the rotational motion's velocity, and linear velocity is the straight line motion's velocity. It's easier to run in a straight line, but it's tough to run along a rotational motion. So linear velocity is greater, so the relationship is v is equal to r omega. You should know this. Okay, and coming back here, this is a relationship between linear velocity and angular velocity. Linear velocity is v, angular velocity is omega. So that apart, okay, 1 second, hold on. So this angular velocity is the distance, angular displacement. It's not the regular displacement by time. It's not the linear displacement. It's angular displacement, which is theta. So omega is equal to theta by t. The angular velocity, you should know, is angular displacement by time, which is theta by t. And the theta is generally, if you are going for physics tuition, maths tuition, they would have taught you theta as in radians. Okay, and so it's radians. Theta will be degree, and it's also in radians, radians per second. It's in trigonometry. I hope you're going for maths tuitions and you've learned the basics of trigonometry, where theta can be in degrees, also in radians. So it's radians per second. This is angular velocity. And angular acceleration is represented by alpha. Omega is angular velocity. Angular velocity. This is angular acceleration. Angular acceleration is called alpha, which is angular velocity by time, not regular velocity by time, angular velocity omega by t. So it's radians per second square. It's radians per second square, because this divided by time again is radians. So that's angular velocity, this is angular acceleration. Okay, and then there's something called an angular momentum, L. Okay, when you're running straight, its velocity will be greater than the rotational motion's velocity, which is omega. So v is equal to r omega. Similarly with acceleration also, with when you're running straight, the linear acceleration is a. While angular acceleration is alpha, and you should know A is equal to R alpha because it's easier to run straight, and as acceleration of the linear motion is greater. But when it comes to rotational motion, supposing a fan is rotating, its angular momentum will be greater than the linear momentum. Okay, the angular momentum for a change is greater than linear momentum. Just the opposite of what happens in velocity and what happens in acceleration. This is called angular momentum. So supposing a person is holding two dumbbells like this and he's spinning around, okay, like this, is going to go around like this in a rotational motion. Can you imagine? So then this, the momentum, the angular momentum is the one which is acting directly upward above his body. In a mass which is going like this, the angular momentum will be m into v in this direction. Linear momentum will be m into v in this direction. Linear momentum. But here the angular momentum L will be right above his head. So that will be greater when compared to linear momentum. So till here you should know everything. This is just very basics in physics.